That's fine. We can just start commentating.
Just talk. Stop and turn around when you see something.
Sure, yeah. Okay, walking through downtown Haiti here, trying to assess the damage and seeing how they recovered from the 2010 earthquake here. It's pretty interesting from an architectural point of view, also just from my own background, having been to several disaster sites, including a few earthquake sites here. So, make our way through here.
Hold on.
Okay. Bridge. I'll let the old lady here. Okay, so we're just gonna kind of make our way through here. It looks like we've got some infrastructure issues here. So probably a broken main or something, we're guessing. We're just gonna wind back here. Oh, wait, puppy. Okay, so if we just kind of look over here, you see this is pretty classic, exposing how there's kind of a different couple of areas of construction there. On the bottom is what's called a rubble infill. They probably put brick in front or something. You can see the remains of some of the brick. And then on top, they put a CMU, put concrete masonry units on top.
What does that mean?
It's mainly, most of this type of construction is masonry construction, so built out of solid units. A lot of what's holding it up, especially for the old construction, is really just plain gravity. The mortar in between the stones, keeps them from slipping out. But obviously in an earthquake, all of that crumbles pretty quickly. If you kind of look up here, you see the floors are made out of cast concrete with rebar, network of rebar in there, and basically the concrete has failed in between the rebar. You look over there, see where the window is, there's a big crack. There's a classic diagonal cracks extending out of the window, and this is something that's very common you'll see in earthquake damage here, especially with this type of construction, is that because the window, as the building shakes, the masonry between it breaks, and so it's cracking from the corners outward, because the way these buildings are built is, especially the newer ones, are built using a concrete frame and then an infill of masonry in between them. And so what's happening is it's stronger at the corners of the frame, but obviously the whole structure is flexing in the earthquake. And so the infill masonry panel starts to crack diagonally between it. If you see right there, you see the exact same thing there. So this is something you see quite a bit here in many earthquake sites. Here. So one thing you kind of really get in these kind of disasters is you really kind of see how they're built and stuff, and you see how they, what the kind of engineering term we'd use is called fail. So when the structure doesn't work. So right here you see in front is that the building has sheared kind of right down, right at where there's a connection point in the frame. And so we see here, this is pretty indicative too of another earthquake damage here, where basically the concrete frame, one corner of the frame has collapsed. And so it's causing the whole other part just to buckle down. And you see how they build is basically they build rebar columns, fill them up with concrete, tie them to the floors where you got floor beams coming across, and then they fill it in between those. It's a very common way of building, and you see it a lot in the third world, especially because it's one of the cheapest ways of building, but it's also not very good in an earthquake. So you see one of the older buildings, you see the bricks on it, and you get a kind of different damage from the concrete because there's more structure inside the brick wall. So here you're seeing where bricks were just kind of popping out of the mortar bases. There. And over here you see the same thing too. Now this is interesting because this has an archway here, and the archways have withstood, in some cases better because they transmit the weight through it. But part of this is that when the earthquake hit, it was kind of an upthrust. It's kind of knocked it and shook off the top part to slide off. So one thing that's pretty obvious walking through here is just the reconstruction has been very haphazard as done, and obviously they've left a lot of the old stuff around. They basically just cleared it, and just people have kind of infilled in as much as they can in between. Right here, you can see this building has kind of withstood it. The frame has withstood a little better, but you see the mortar in between, and you see the concrete blocks slumping in the middle. Actually, it looks like the frame starts sliding this way. Now, looking at that, those blocks are probably new. The frame might have survived, and they might have filled it up, but it's just that in the earthquake, the building was no longer level. And so as they're just trying to build on a non-level surface with new blocks, they're just kind of sliding and slumping.
As we pull up here, why don't you give me sort of a wrap-up and an overview of what you think about the state of things as you're seeing?
Well, it's clearly pretty rough. I mean, it's not very good at the moment here. I mean, there's certainly a lot of work to be done here from the architectural side. A lot of these buildings that people are occupying move back, our damage should probably be torn down. I mean, we shouldn't be having people trying to in them or trying to move them, but this is a problem with, the third world, is that it's not like they can just tear down and build completely anew. They got to try to figure out it costs money to tear it down, it costs resources to build anew. At the same time, sort of a lot of the new construction that you're seeing is not that good either. And that's just a function that they just don't have the resources to do it. For that matter, the building codes, whatever they have, are probably not enforced at all. So at this point, it's mainly just going to be a challenge of, trying to make what they have here, as safe as we can, trying to get the resources to basically build up, better construction, more earthquake-resistant construction. Yep. Sure. You want to get this? Check out the rebar. So right there you see where the concrete pier has cracked and the rebar is just exposed like spaghetti. Okay, we're standing here in front of, I presume was probably a cathedral at one point here for Haiti. You can see there's quite extensive damage to it. Most notable is obviously any of the windows have all been broken out here, and probably just due to when the earthquake just shaking it, just naturally shattered. But if we back up and look through that one main central, you can see there's a much larger window in the back. That top of it appears to be sheared off from the force. And now I can kind of see up there bits of steel, which probably was part of the roof of the building before. And so what happened is that as the earthquake kind of came and hit, it probably just kind of lifted it up like that, and then the roof basically pulled off of the building, and as it did, it started tearing off the masonry that was connected to below. And that's just looking at it would be my read about that damage there.